Okay, let's start. Can you hear me?
Yes, we can.
Okay, great. So welcome everybody to this information session about the ERC grants. My name is Christian Oswald and I work as a scientific officer at the ERC Executive Agency. I would like to welcome also the other speakers of this session, the ERC grantees, Katarina Dolioni and Andrzej Pecha. And for the Czech National Contact Point, Zuzana Čapková, the co-organizer of this event. This session is part of the International Conference on High Energy Physics, and I would like to thank the organizers for offering us this slot in their program. The conference was planned to be held in Prague, and personally, I would have loved to be with you in Prague because I have still many good memories from my master's project at Charles University in Prague. So now what can you expect from this session? We will start with a brief introduction on the ERC grants, and then the ERC grantees will present their projects and their experience with the ERC. And last but not least, Zuzana Čapková will present the support offered by the National Contact Point. A few organizational remarks. Please stay muted during the session. If you have questions, please send them us through Slido. For this, please go to slido.com, for instance, on your mobile phone, and there you type the code ERC info. This brings you directly to the form where you can submit your questions, so no registration or something is necessary. You also can vote for the questions of the other participants if you would like to. Okay, and now I will start with my introductory presentation. I would like to address three main questions in my talk. First, can you apply for an ERC grant? Then why should you apply? And finally, how to apply? So the really good news is that everybody can apply for an ERC grant. The ERC funds individual scientists, so no consortia. And the ERC has a bottom-up approach. That means there's no predefined program and researchers from any field can apply. Due to the topic of the conference, today's information session has also a focus a bit on physical science and engineering, but also potential applicants from life science or social science and humanities will find a lot of useful information, I'm sure. So there's also no limitation on the nationality of the applicants. So you can be from any country of the world and apply from an ERC grant. So now you might ask, maybe, hold on, why is it then called the European Research Council? And that is because you're required to carry out your funded project at a host institution, which is located either in a country of the European Union or one of the countries associated to the framework program. Examples of such associated countries are Switzerland, Israel, or Turkey, and there are many more. So now, why should you apply for an ERC grant? There's, of course, one obvious reason, because you need money for your research. The ERC has the approach of giving very generous grants for a long duration, for 5 years. The idea is to give you all the freedom and all the independence to fully focus on your research. There are different grants for different career stages. There's a starting grant for applicants up to 7 years after their PhD and who are just in the process of building their own group. Then there's a consolidator grant, and finally an advanced grant for the leading researchers of their field. As you can see, the grant amount increases with the career stage. But that's not all. You can apply for top-up money for an additional up to 1 million euro for one of the following reasons. If you relocate to the European Union or to one of the associated countries to carry out your project, you can claim the relocation expenses. Also, if you want to purchase major equipment or if you have to pay for access to large facilities, you can ask for this extra money. And finally, also for any other major experimental costs, you can claim this extra money. But money is not all. The ERC grants are also a quality label. Researchers compete for the grants at an international level, and the proposals are evaluated by world-leading scientists. So getting an ERC grant means something. However, there's a realistic chance of getting an ERC grant. The success rates are about 12%. So now, what is required to win an ERC grant? The ERC has one sole criterion of selection, and that's excellence. Excellence is evaluated along two axes. First, the excellence of the research project. You're asked to present really an ambitious project with a brilliant idea, a lot of novelty, and you need to push the borders of your field. At the same time, you need to demonstrate that your project is feasible within a project duration of 5 years. And then, secondly, excellence is evaluated in terms of the researcher. You have to demonstrate that you already are one of the leading figures in your career group, at your career stage. If you now consider to apply for a starting grant, don't be put off by this. The entrance criterion is one major result published either without your supervisor or with you as a main author. I would like also to highlight in this context the efforts of the ERC made towards equal opportunities. Parental leaves and also unusual career paths are taken into account in the evaluation. So now, how does an ERC application look like? There are different parts, and in today's presentation, I focus on the scientific parts. First of all, there's an extended synopsis and your CV and track record. You see this on the slide in the orange box, and I call this the business card of your project. Then there's the full scientific proposal and also a part where you explain the resources requested for your research. So how is now all this going to be evaluated? There are panels of about 15 world-leading scientists, and they look at the proposals in a two-step process. In the first step, they only look at the business card, the orange box. And on this basis, they decide if they want to promote the proposal to the next step. At the second step of the evaluation, the panel members look for the full proposal. They also invite external experts to provide a review on their proposal. And finally, You will be invited to present your proposal in an interview during the panel meeting. So I would like to share some tips and tricks for your application. I'm sure our grantees who will present later can even give you more detailed tips. I would like to highlight here that really key for a successful ERC application is a brilliant idea. And so check the novelty and the excellence of your idea. And for this, it's best to ask your peers, your colleagues, and maybe other ERC grantees for their opinion. However, there's not only the scientific preparation to be done, there's also some administrative stuff. For this, we can just recommend to start early and to ask for help. Your host institution and your national contact point can support you. And finally, please always keep in mind that your proposal is evaluated by scientists. It's not EU bureaucrats like me who have a look at it. So please make it as reader-friendly as possible for scientists. What you can have to keep in mind is that the panel members are from different fields. So they have a look at your proposal from a perspective of a generalist. If your proposal makes it then to step 2, they, however, invite experts on a specific field of your proposal, so specialists to look at it. So you have to convince both the generalists and the specialists. Always, also a good advice is always to provide context to what you write. For instance, if you have career breaks or in your publication list, you can, for instance, comment on the content of the publication, the impact in the field, and your contribution. Always sell yourself, but don't oversell. And finally, as said before, always ask for feedback from grantees and colleagues. Now, finally, I would like to make a few administrative remarks, and I would like to limit myself here to the most relevant for you. The ERC receives its budget from a 7-year framework program, and we are just in the transition to the next program, Horizon Europe, starting in 2021. What you can expect from the ERC is, first of all, continuity. The status of the ERC, the grants, and the selection process, this will all remain the same. Also, the eligibility windows for the consolidator and starting grants will remain the same with the 1st of January as a reference point. There's some particularities for the 2021 calls. The submission deadlines will be postponed to 2021, and there will be no synergy grants. Regarding the budget and the associated countries in the new framework program, this is still under discussion. And for instance, in the case of the UK, it's not clear what will be their participation. So this now brings me to the summary and outlook. I hope I could make clear that really scientists from any country and any field of research can apply. The grants are very generous and for a long duration, and the ERC grant is really a quality label for your research. The ERC will continue its activity in the next framework program, Horizon Europe. If you look now for further information, you can go to the webpage of the ERC. You can also follow the ERC Twitter channel. And I've seen also on the ERC YouTube channel, there are also videos for potential applicants who want to get some tips and tricks. And if you have now questions, you can join us at Slido and submit it. We will either answer the questions right away, or there is a dedicated Q&A block at the end of the session. Okay, that's it from my side. And maybe we ask Susanna if there are already questions on Slido.
Okay, so thank you for your first presentation. I am checking the Slido and I can see that we have only two questions. So the first one we can maybe keep for our two ERC grant holders, and then you can also comment. And then we have here one question concerning 12% success rate, whether you can just comment on that. The 12% success rate corresponds to which field and which ERC grant? So it's not very easy to answer just briefly, but if you can comment on this, Christian.
So the success rate is across all fields and also all grants. It depends a bit. Sometimes it's 11% or 13 or even 14%, but that's the success rate. I can also give the reason for this. You submit your proposal to a specific panel. There are in total 25 panels, and the budget of the panel is adjusted according to the number of submitted proposals. So if a panel receives a lot of applications, this means also that the budget is higher and the panel can fund more proposals. So there's no, I just can recommend to submit your proposal to the panel which is best or matches best your research, and there's no advantage in terms of success rate to submit to one or the other panel.
Okay, thank you. Can I raise another question? So I can see now more questions. If you can comment on synergy grant. So one of the questions, why there is no synergy grant in 2021? This was already the case for this year, which means that we will have a whole of 2 years.
So the reason for next year is that the transition to the new framework program. So the new framework program only enters into force on the 1st of January 2021. And this means we cannot publish the calls before the 1st of January. Usually the starting grant would be already published, I think some time in autumn. And basically now we have to squeeze all 2021 calls into the next year, and therefore we cannot do the synergy just because of operational reasons.
Thank you very much for this explanation. And maybe the last question before we move to the next presentation: what's the composition of the panel like, the fraction of theorists, experimental physicists?
So this depends, of course, on the specific panel. But if you want to get an idea, I can recommend on the ERC webpage, there's always the list of panel members of the previous years being published, also for reasons of transparency. And there you can get an idea of the composition of the panel.
And that's it. I think for now we can keep the first question for the upcoming presentations. And now I think you can give the floor to our first ERC holder.
Yes, so Katarina, please, the floor is yours.
I'll try and share my screen. Okay. Should be able to see the screen now. And the presentation. And okay. Good. So thank you very much for giving me this opportunity to talk about the story behind the ERC grant that I have, because in the end, every grant is a story. And as it was said in the previous presentation, it's the way you tell the story matters a lot. So I hope I can tell you how the ERC contributes to making the most of LHC data. So let's start with the acronym. This is not quite an acronym, but every grant has to have an acronym. I think the next presenter will have a much better acronym than mine, but at least I'll tell you what dark JETS means. So dark is quite clear what the problem is here. It's dark matter. We heard a lot about it in the previous week, and we'll hear about it today in the plenaries and also in the panel. Dark matter is a problem in the standard model of particle physics, in the sense that there is a lot of dark matter, but there is no particle explanation so far. So of course, there's a lot of possible solutions. And one of these possible solutions is that dark matter is an invisible particle that has very weak interactions with the standard model. That's the reason why it's invisible. But it's also massive, so that helps. So this is why we call it weakly interacting massive particles. And the two things combined, its mass and its at least weak interaction with the standard model, allows us to detect it with a lot of experiments. So not only we have hints from astrophysics, but we also have indirect detection experiments, direct detection experiments, and collider experiments. And to tie everything together, one needs theory. Again, if you want to know more about this, it's in the sessions and the link below. There's some really good talks there. And what I will be talking about is what I do for dark matter, or at least I think I'm doing for dark matter. That is working for dark matter at searches at the LHC. So the LHC, the Large Hadron Collider, can produce this kind of invisible particles. And it can do so in more or less controlled conditions, in the sense that we know what kind of particles we're colliding. We're colliding protons, and protons are made of quark and gluons. And we hope that in some of the collisions, probably very few because this is very rare, we will produce dark matter particles. So experiments like ATLAS and CMS, I work on ATLAS, that's why all the results are ATLAS-centric, can probe what happens in this blob here. What is the dark interaction between the standard model and the dark sector? And one can do that using the decays of a mediator particle. Like in all the forces that we know, the weak force has a mediator that is the W and the Z boson. The electromagnetic force has the photon as a mediator, and the strong force has the gluon as a mediator. So why not, assuming that there's a mediator between the standard model and the dark matter in terms of a new force? And this also gives us an advantage because we can actually see all kinds of decays of the mediator particles. And if this mediator particle is produced through the interactions of quarks and gluons from the initial state protons, then it should also decay back into quarks and gluons. And this is what makes the JETS, dark JETS, part of the grant. So in this proposal, we are searching for signs of dark matter in final states that contain jets of particles that come from the quarks and gluons. So I'm talking a lot about we. It's not just a single effort. Once you have an ERC grant, you can work with very nice people. So this is the dark JETS team at Lund University. So the team is made of one postdoc at a time. So we had Will Calderon, now it's Brookhaven National Lab, and now Yannick Geisen is working with us. Then we supervise PhD students. So Eric and Eva, they are both defending their thesis this year. So best of luck to them. And we also have a master student that was working a lot with us and now transitioned as a PhD, Alex. And this is only a small part of all the people that we interact just in Lund University working on this particular project. There's many master students and bachelor students. And that I think is also one of the nice things about doing a project like this in a university context, that there's a lot of people that you can work with and can be enthusiastic about solving the same problems as you. So what is the problem that we try to solve? It's a big science problem. The LHC is large, Large Hadron Collider. And the problem we want to solve is that we have too much data. We actually need that because the dark matter signals we're looking for are quite rare. So we need to collide many particles many times in order to produce this kind of signals. The other issue is that their backgrounds look the same and they're much larger in magnitude. So we could just say, let's just record all the LHC data so that we just then sift through this data and find dark matter signals. Not that easy, because if we did that, it would take 400,000 petabytes per year. So this is maybe larger than Facebook, we don't know, because Facebook doesn't publish their numbers, but it's a lot of data. So this is not feasible with the resources we have. And for this reason, the LHC experiments need to select interesting events. So this is what is done by a trigger system, more or less in real time. And in real time, we're talking about milliseconds, microseconds, and so on. So you have collisions of known particles of protons at 30 megahertz. And each one of these collisions is 1 megabyte of information. So you have to weed them out. And you can only record, if you want to do an analysis, by recording the entirety of the event and then analyzing it later at about 1,000 events per second. And the trigger system helps you select what is interesting and selecting only 1,000 of these collision events per second to record it, to store and analyze later on. And in order to make this decision, the trigger system has to analyze the events at the quite fast. So this will come useful later. So this is what most LHC experiments do, not all, but it can pose a problem once we're looking for rare dark matter processes like this, because we're just looking under the spotlights of the events selected by this trigger system. And we're not really shining a light on dark matter mediators, because we would throw them out. So this is what is problematic. So selecting interesting events works for most of the LHC physics program. And we've seen at this conference some really beautiful results of the Higgs coupling to muons. That's also a rare process, but it doesn't have the level of backgrounds that this kind of dark matter processes have. So it's not optimal. Oops, sorry, this went out. Okay, back. So it's not optimal for rare processes that have high rate backgrounds, because with this system, we cannot record and store the old data, and the trigger will discard both the background and the signal. So this prevented us from being sensitive to low mass dark matter mediators decaying into jets. And when I say low mass, this is all relative. Low mass with respect to the energy scales that the LHC can have. So we're looking at less than 1 tera-electron volt for the mass of the mediator particle. And if you look at this plot that is with the dark matter mass and on the x-axis and the mediator mass on the y-axis, the interesting region where the model can produce the right amount of dark matter that we have as a relic density is closer to the low mediator mass parameter space rather than the high mediator mass parameter space. And because of these trigger issues, we could not reach this parameter space with anything except for experiments that had already stopped running. So this is what this purple curve means. This is the constraints that were given by other experiments, and on the y-axis you have the strength of the interaction between the mediator and the quark. So the higher, the more frequent the processes are. So the solution that we propose, and the main technical idea behind dark jets, is to move from an asynchronous data analysis where you record and store the data and then you reconstruct and analyze it, to use the trigger to do a lot of the analysis for us. So this is what we call the real-time data analysis, to reconstruct and analyze the data as soon as it's read out, so that we don't need to save the entire raw data. We can just save smaller final state information. And this is something that is also done in CMS with the name of data scouting, and on LHCb as TurboStream. So in Atlas, we call it the trigger level analysis, which is also a 3-letter acronym. And in this sense, we use the trigger system to give us the information to search for new physics, to just take out a small amount of the event, just to reconstruct the jets, and avoid completely trigger decision. We could do that because the event size was much smaller. So you see the size of the trigger level analysis event relative to the full event in yellow. And that allowed us to collect orders of magnitude more data. So you see on in the plot on the right, there's the x-axis, this is time as in an LHC run, and on the y-axis in the thousands of events per second that you can get out of this trigger system and then analyze. So the yellow is smaller than the blue. The blue is what we're doing with dark jets. So while the idea is simple, the implementation, at least at software and the large-scale deployment, wasn't too easy, and this was quite a big part of our time. There's also the question of whether a reduced data format good enough for discovery, and we had to demonstrate that that was the case. And also do the statistical analysis of this kind of data. There's a lot of data, so this is not something that you can, you have to be quite careful of what you do and how you handle it, also because the signals are so small. And this is not just something that we did in isolation. It's there's a lot of collaborators in this analysis from universities all over the world. And the picture is just a small part of the team. So what happened to this wide open parameter space after darkjets and also after other searches from VMS is that we did cover quite a lot of it. There's more, and we will go there. But I wanted to highlight the two techniques that we used to cover this parameter space. One is the trigger level analysis technique. So we made the event size smaller, but we also tried to use regular data taking techniques and reducing the background. And this is what we call the DiGET plus ISR signature. So we have two complementary parts of the parameter space that we covered with the searches. And then finally, we wanted to put everything in a global context. So we're talking about dark matter, but when you talk about dark matter, you can't forget that there's the experiments that really can tell what dark matter is because they actually measure dark matter, don't create it. It's direct detection and indirect detection. So how do we compare results of these experiments? This was also a question that was asked in the European strategy update of particle physics. It's one of the big questions. And one wishes that it can be done in a most model independent way possible, but in reality, you can only do this in the context of a model. So we are aware that these kind of models that we're using are quite simple, but if we specify the models and the parameters and are aware of the limitations, then we can make plots like on the right-hand side, where we put the collider results. So you see here the DiGET triangle here. In terms of, this is again, a measure of the rarity of the interaction, and this is dark matter mass. And there's a complementarity between the experiments in the direct detection experiments and the collider experiments. And there's a lot more discussions that we're having with the indirect and direct detection, and something that needs to come, because this is not the end of the story. So this is something that I had put in the grant proposal. So what was my plan? I was planning to have 4 separate so-called work packages, and one of which was already covered by internal funding. So if you want to answer questions, what happens if I already have a grant, then I can answer that later. And the other 3 were new physics at low masses, new physics in boosted topologies, and then the interpretations. And I had a number of papers that I planned that are arrows in the original plan there. And what really happened is that we spread out the publications differently, because not everything goes according to plan or is in your hands, especially in a large collaboration. But I'm happy to say that the little tick boxes on the left means that we reached all the project milestones. And we also reached all we also organized, chaired, and canceled conferences, unfortunately due to COVID, and gave conference talks. So the dissemination part of the project is quite interesting as well when you have an ERC grant. And the communication and outreach is also something that is useful. It's a different kind of audience. It's not just scientific audience, but we contributed to newsletters and feature articles. And we have a lot of fun organizing the ICHEP masterclass. So it's when students from high schools come and they talk to you about research and they become physicists for a day. So that's one thing that I think made this project quite nice. Once you have questions and then you can answer them through an ERC grant. So we wanted to find signs of dark matter in jet final states at the LHC. Then it's inevitable that after 4 years, like now, you get many answers, but also many new directions for future research. And these are the things that I want to do, that I could talk about them for quite a long time, but I guess we don't have very much time in this particular talk. So I wanted to also highlight the fact that once you have a grant like this, then it's easy to find the like-minded people and people you can collaborate with. So we have a number of ongoing collaborations related to dark jets. One is a network of physicists from mostly Europe, but also the US, that led to a submission of an international training network. And this gathers real-time analysis experts from all the main LHC experiments, because we realize that what we're trying to do is something that has a long-term future, or at least we hope. So there's more ERC grantees that are involved in that. We also went a bit beyond the boundaries of high energy physics with an interdisciplinary advanced study group that is in Lund, that has members from all kinds of disciplines, including law and social sciences. So this is a very interesting experiment here. And we're building up a research school starting in January on intelligent instrumentation in physics together with Hamburg. For the prospective grantees, there's other networking opportunities, and I suggest you take anything you can. This is probably going to be discussed in the next talks, but the visiting fellow program is especially interesting because you can go and spend time with an ERC grantee at their institute for a while. So concluding here, sorry, I'm a little out of time. I wanted to just conclude with what we did in DarkJets. So these are the main milestones. We wanted to advance real-time analysis method at Atlas, because ultimately we want to do more physics with fewer resources, and this will be important at upgraded LHC experiments where the data rates are much higher. We defined a framework for dark matter searches at the LHC and looked for this kind of particles in a challenging but promising regions. And we trained postdocs and students on dark matter physics and big science too. So my last word is you should think big and about the science that wouldn't happen without you or without this grant, because this is really a unique opportunity to pursue your research questions, work with talented researchers, and build networks that can last throughout your career. And yeah, the thanks to the people that I'm very grateful to these people that without which I would not be able to be here to talk about this grant. So thanks to everyone.
Thank you, Katarina, for your presentation. I think this gave us already like a good insight into the life of a ERC grantee and the life in the project. If I remember correctly, there were 1 or 2 questions concerning the LHC experiments. Susanna?
Yes, thank you.
Maybe we can give
more.
them directly to Katarina so she can answer them.
Yes, I will ask. Thank you once more, Katarina, for your very interesting presentation. And I have here the first question for you. Okay, so I think it now disappeared, but yeah, so I see it. So now we have 2 likes, so it is one of the most favorite questions. So what is general advice to write a successful ERC proposal when you are part of large particle physics collaboration, such as Atlas or ALICE at LHC? So this is the first.
Very interesting question. It's one that a lot of people have asked me before I applied. So are you sure that you're pinpointing that? And what I did, at least this is what I personally did, is that I took that particular picture for the interview where the entire collaboration was set up in the word Atlas during one of the collaboration weeks. And then asked people, look, can you find me? And generally, no. I mean, the answer is there that these big science projects are collaborative by nature, and we have author lists of 3,000 people. But I think each of the individuals in there has a unique path and story and the things that they've done, and without any of us, the experiment wouldn't really work. So the suggestion from me would be to try and find where you have been one person that has made really a difference and build up on that and drive the experiment towards something new. And I guess it seems easy to say, but the more you think about it, the more you see what your story is, and then you can tell that story and stand out.
Thank you. Actually, I have another question linked with what you have said. In your opinion, what was the crucial part of your proposal that distinguished it from other works in Atlas?
Interesting. I don't know, maybe stubbornness. Because this was a thing that wasn't necessarily thought possible or easy. And it took a lot of somehow uphill work to get it done, the implementation especially. So I think the fact that there was something like this, something that was difficult and that would unlock physics possibility, I think that was at least I'm looking at the referee, thinking about the referee report. That was the thing that people said, this is a good thing to have the technical side and the performance side and the lots of work, like lots of hard work side, then gives you also the physics results.
Thank you very much. I think for now, we don't have any specific questions to ask, but I think now it's time to give the floor to our second ERC grant holder. So thank you for this moment, Katerina, once more for your participation. And I will ask Ondřej to continue.
Okay, can you see my screen and hear me?
Yes, we can.
Yes.
So the floor is yours. Thank you.
Okay, thank you very much. So hello, I'm Ondřej Pejcha. I'm at the Institute of Theoretical Physics of Charles University, and I'm an astronomer. So that's somewhat off from the field of particle and nuclear physics that this conference is about. But I hope to explain a bit about my project, my ERC starting grant Cat in Hat, which started in January 2019. The full title of my project is Catastrophic Interactions of Binary Stars and the Associated Transients. So I will actually spend most of my talk trying to explain my title because I imagine it contains some jargon that non-astronomers might not understand. But probably everybody knows what a star is, and I can tell you that many stars live in binaries where two stars orbit each other and go around each other. And it can happen that in some cases, these two stars will strongly interact with each other, sometimes even catastrophically. And as a result, they make something that astronomers call a transient. So to illustrate better what it is, I show a little repeating animation of a typical astronomical transient. So astronomers that are interested in things like this often take repeatedly images of the same area of the sky. And sometimes it happens that a new object appears, brightens, and then eventually disappears. The time scale of these brightenings or astronomical transients is very wide. It can go from milliseconds in some cases through minutes, days, months, all the way to years. In history, astronomical transients were called new stars, and perhaps you've heard of some of the categories that astronomers assign to these things, such as novae or supernovae or cosmic explosions. But generally speaking, the buzzword for describing these events is astronomical transients. The astronomical transients are quite crucial to my project because this field has been booming in astronomy, and the reason for this is the extremely fast growth of available data on the sky, which allows to detect more transients, learn more about them, detect the exotic ones that are associated with rare and infrequent phenomena, and to learn something new about these infrequent phenomena. So, but why should you care, right? You are interested in fundamental laws of physics in some sense, but everybody should care about astronomical transients. And the reason for this is that they stand behind the origin of chemical elements on the Earth, solar system, and the universe in general. So this picture shows the periodic table of elements where each element is color-coded according to what astronomers think is its origin in the universe. People generally know that hydrogen and helium and a little bit of lithium were made in the Big Bang, and the two heavier elements, beryllium and boron, were made by cosmic ray fission of even heavier stuff. But the rest of elements from carbon up were made later in the history of the universe in some process that involves stars and often stellar explosions. So one exception to explosivity of this are dying low mass stars, which are shown in yellow here. These are deaths of stars that are similar to our sun, that make a substantial amount of some of the heavy elements and some of the light ones like carbon and nitrogen. But here the final death occurs over thousands or hundreds of thousands of years, and it's not very explosive. But the other three possibilities that are shown in this diagram are quite exciting. So one is exploding white dwarfs that are shown in blue, and these exploding white dwarfs make a lot of elements of the iron group in this region of the space. To explode a white dwarf, you actually need to have it in a binary star. So that's one connection between elements, explosions, and binary stars. These exploding white dwarfs are thermonuclear type 1a supernovae, which are also used to track the expansion of the universe and to study the dark energy. With green color, this picture shows elements that are formed in exploding massive stars. So those are stars that are initially more massive than about 8 times the mass of our sun. And they also make iron group elements and also elements that are a little bit heavier than that, but also a lot of the lighter elements. And the nucleosynthesis, or the importance of these exploding stars, is not only the new elements that are created in the explosion itself, but also as a means of spreading the elements that were made in the preceding evolution of the star, and that's mostly the lighter elements that are here. And we know that many of these exploding massive stars are in binaries. In fact, for massive stars, the binary diffraction is much higher than for stars that are similar to our sun. And finally, the orange color shows the heaviest exciting elements like uranium or gold or platinum. And astronomers think that these elements were made in explosions where 2 neutron stars collide with each other in almost the speed of light. What is interesting, as you can see, is this question mark right here. This illustrates that our knowledge of the origin of elements is a continuous process. It has started decades ago in 1950s, and still up to this point, some of the even fundamental questions about the origin of elements are not solved. And just about 10 years ago or so, most astronomers would think that the heaviest elements that are here shown in orange are not formed in merging neutron stars, but instead in exploding massive stars. So in just about 10 years, there has been a big paradigm shift in this field. And the evolution continues very quickly because of detections of gravitational waves and other observations, which I will discuss a little bit later in my talk. So to explain to you what my ERC grant is about, I need to show you first a bit about evolution of stars. So stars are born in nebulae composed of gas and dust, which fragment, cool down, and collapse into little clumps. The little clumps then give rise to individual stars. If the star is initially similar to our sun, relatively small, it can live on for billions of years, and at the end of its life, it will expand into a red giant, shed its surface layers in a planetary nebula, and leave behind a white dwarf. A white dwarf has mass of about 60% of the mass of our sun, but is the size of our Earth. So there are some extreme conditions happening in white dwarfs. Those white dwarfs are made primarily of carbon and oxygen. Even more extreme objects are made for more massive stars. If a star starts with more than 8 or 10 solar masses in the beginning, it will evolve much faster. Its lifetime will only be a few millions of years. It will expand as well to a red supergiant, and it might explode at the end of its life as a supernova and leave behind a neutron star or a black hole, two quite extreme objects of stellar astrophysics. A neutron star has mass of about 1.5 masses of our sun, but it's comparable to the size of Prague, where this conference should have originally been held. However, very interesting things can happen when you put two compact objects like neutron stars or black holes or even white dwarfs very close together. In such a case, the two objects will orbit around each other, as is shown on this movie. They emit gravitational waves, start coming closer together, and eventually collide. And this collision is accompanied by an explosion and potentially, in some cases, a bright optical transient. In gravitational waves, this was observed directly for the first time in 2015, and the Nobel Prize followed 2 years later. The same year, LIGO and Virgo collaborations detected for the first time the collision of two neutron stars that supposedly, according to what astronomers think, are responsible for the heaviest elements that we have on Earth and in the universe. So this observation truly opened a new window into studying astrophysics of these compact binary stars, and has led to increase of effort in trying to understand where do these objects come from. What is the origin of these gravitational wave sources? Now, the central problem that people have been trying to solve for a long time, and which my project also addresses, is shown on this very schematic sketch. If you remember the stellar evolution that I showed initially, stars typically evolve from small to bigger ones. And this evolution has to happen so that in the end, we end up with a small compact object in the center. So in the most explored model for making these binary gravitational wave sources, we have to start with two normal, relatively massive stars on a wide orbit. So each of them can develop and make the compact object. However, the two compact objects that are a result of this evolution has to end up very close together on a very small orbit so that they can merge by emission of gravitational wave emission within the age of the universe, which is only 13 billion years or so. Gravitational waves are very weak when the two objects are far from each other. So how to do this? This problem was identified already in 1970s, and it was suggested that some kind of a catastrophic interaction of the binary star has to happen that transforms a wide binary star into a close binary star through a schematic evolutionary pathway that's shown here. The result of this could be either a close binary, such as the progenitors of gravitational wave sources, also many other things that are of interest in stellar astrophysics came through this evolutionary pathway, or alternatively, during this catastrophic interaction, the two stars can merge into a single object that is potentially very weird and can explain some of the weird stuff that astronomers are seeing. Despite the fact that this process has been studied since 1970s, it remains one of the major unsolved problems of binary star astrophysics. We do not fully understand what happens to the orbital energy of the binary star during this process. What is the physics of the brightening or transient that accompanies this catastrophic interaction? And this is truly a new spin that happened only in the past 8 or 7 years because of all of the new data that is available from the surveys. And of course, as always in astrophysics, it is unclear what magnetic fields are doing, and we would very much wish that somehow they get amplified during this catastrophic binary interaction. But how, it's not entirely clear. So what I'm bringing into this problem is the realization that many of these catastrophic binary interactions are accompanied by a long-lasting loss of mass in the form of a sort of a garden sprinkle spiral, which is illustrated on this short repeating animation right here. So what is my project about? It can be understood by looking at a timeline of events that are happening to the binary star. This is sort of a logarithmic compressed cartoon timeline of a binary star long before, as it evolves to the catastrophic interaction, and then it evolves after and eventually becomes relatively normal and quiet. And so far, astronomers have used two types of methods to study the events that are happening on this timeline. First is one-dimensional, spherically symmetric stellar evolution code that is typically used to understand in extreme detail evolution of our stars. But because of the nature of this tool, it works very well only very much in the past when things are really quiet, or on the opposite end when the system has evolved and settled down and things are quiet again. To complement this, people have been using fully compressible hydrodynamics, which is multidimensional, but can only be applied due to limitations on our computing infrastructure, only to a few orbital timescales of the binary close to the catastrophic interaction. So in my project, I'm proposing to develop and bring methods from other fields to this problem. This includes low Mach number magnetohydrodynamics and multidimensional moving mesh radiation hydrodynamics, which are probably all buzzwords. But these these tools will allow us to fill in the gaps that have existed in our understanding of the sequence of events. And of course, although the events here and here are not extremely violent, they are very important for as initial conditions or as a way of connecting all of this together. And there is a potential for discovering that things might be different than what we have thought so. So I will conclude with a short slide about my path to the ERC, and there might be some questions about it. I applied twice. The first time was unsuccessful, but the second successful proposal, in my understanding of the process, really emphasized the high risk and correspondingly high gain, which in the case of my proposal was the development of new methods to study this old problem, as I explained on the previous slide. So that's all for me, and I'd be happy to receive questions.
Thank you very much, Andrei, for your very interesting presentation and explanation of your research. I think we have some questions, so you can comment, you or also Katerina. So we have here kind of comment concerning the novelty in your research in ERC grants. So one of our participants commented, I would say that the criterion of novelty is a tricky thing to use to grade the applications. As scientists, we build our work on existing experience, and I think it continues. Also, the advice not to oversell isn't a good one, because everyone oversells. The applications which don't oversell themselves have, higher chances to be rejected. Would you like to comment on that based on your experience, Andrei and Katerina?
Yeah, I don't know. I guess I don't have much to say. I mean, I was not judging the proposals, so I mean, I clearly did some things wrong the first time, which was reflected partially in the reviews, and in some sense, I collected experimental data on what these criteria mean, and I think I improved on the proposal the second time around. But I mean, in some sense, I agree. It's hard to say what is novel and what is not, and people might disagree. Yeah, and I guess that's what I can say. Maybe Katarina can comment more.
Okay, thank you very much.
I guess I'll say this might be a limited for high energy physics experiment where it's impossible to make an experiment happen on your own. And I think an admission in the proposal itself that you are collaborating and you're working with other people is necessary in these cases. Like if you try not to say that, then it sounds unreal, like it cannot happen. And it's about being nice and recognizing other people as well. So in the proposal, I had an idea that was that I discussed with colleagues from a competing experiment, so-called competing experiment. It was something that we talked about with people from CMS. And they were prototyping, and we talked about and said, why let's make this stronger by having it also on the other side of the ring. And this was actually in this kind of thing was in the proposal. So I don't think that being unique and the only one doing something is one of the most important criteria. Of course, I could have had a reviewer that rejected my proposal saying, look, other people are already doing it. Why are you doing it too? Do something else. So this comes down to individual reviewers in the end. But I think being honest about what you're doing, what the discussion and what the crediting also of the ideas comes from is important in these grounds. And I think the second was about overselling. It's a really fine line, I think, there, because you can't undersell for sure. But if you oversell, then you really are there's a list in an Excel format, I think, on the ERC website of all the second stage reviewers. And those people know exactly what's going on in your field. So you can't oversell, because think about overselling in interface and you wouldn't do it, I think. So I think it's always a balance, and being nice, I think, matters a lot. So that's generally my advice.
Thank you. Thank you. Christian, would you like to add anything?
Yes. I would like to comment on the remark that novelty is something highly subjective that can be used to promote a proposal or to kick it out. And first of all, I would like to comment that, of course, every evaluation has a subjective component. That's quite natural, because it's like humans who are evaluating the proposals. But please keep in mind, the approach of the ERC is not to ask one reviewer to review the proposal, but there's a big panel, and then there are several experts from the field of the proposals having a look at it. So I would say the chance is close to zero that all of them are wrong assessing the novelty of a project. And if you still think so, maybe you haven't explained the novelty of your approach enough in your proposal. Also, I would like to say, inside the panel, there's also a kind of self-control between the panel members. Because if one panel member wanted to promote one proposal, then of course the others would definitely protest. And yeah, I mean, you're all researchers yourself, and yeah, I think your ethical standing you would not do this. So yes, there's a subjective component, but this is leveled out by the larger number of reviewers that are having a look at the proposals.
Okay, thank you. So I think now we can move to the last presentation. So I will quickly prepare it. So now it's my turn. I hope you can see it well. Of course, I would like to remind you of the opportunity to raise questions. You can see in the right upper corner, all of us, the link to the Slido and the hashtag. So please take this opportunity to send us more questions. There will be also some question time after my presentation, which is the last one. and it will be dedicated to the role of the national contact points for ERC grants, and I will also present the support offered by the Czech national contact point. So in general, ERC national contact points provide support to ERC grant applicants, but also ERC grant holders. It means at application stage, but also at the implementation stage. And it is important to stress that they provide this support at national level because the ERC cannot be present everywhere. So that's why there are these contact persons in each country to inform, to raise awareness, advise those who are interested in the ERC. Regarding the location, the ERC and CPs can be located in organizations of different type. Concerning my case, in the Czech Republic, it's the Technology Center of the Czech Academy of Sciences I work for, and it is the main contact institution for those who want to get more information about the framework program and opportunities under currently Horizon 2020. These contact points are present not only in EU member states and associated countries, but also in some non-European countries such as Australia, in the countries of Latin America, in South Africa, etc. You can find the complete list of NCPs on the following link you can see on my slide. And if you want to get more information about the institution I work for, you can also visit the website of the Technology Center. And I would also recommend to visit the National Age 2020 portal, which is in Czech. Concerning the national support for ERC applicants in Czechia, so we offer certain annual activities. So the first one is National Information Day about the ERC, which is held annually, and it is a conference type event where we inform not only about funding schemes, about evaluation process, etc., but we mainly try to connect potential ERC applicants with successful ERC applicants in order to share the experience and give them more practical information. We also organize specific workshops on how to write a competitive proposal. These are two workshops, so divided into two parts. The first part for a 2-day event where we try really give an intensive training on how to write a proposal, also in cooperation with the ERC grantees who can give you some tips, recommendations, how they were proceeding. For those who were invited to Brussels or remotely this year for panel meeting, we also prepare mock interviews for ERC starting and consolidated grant applicants together with mainly one person, Professor Zdeněk Strakoš from Charles University, who is the former ERC Advanced Grant Panel Chair. And all these events mentioned so far are always prepared in collaboration, in close collaboration with him. And we also benefit from the presence of other ERC stakeholders. We invite to the National Information Day, for example, Professor Tomáš Jungwirth, who is a member of the ERC Scientific Council and who can give us the latest news, what is happening in the ERC. And we also appreciate very much the collaboration with the ERC grantees and also evaluators. So you can see on one of the pictures on the right, you can maybe recognize Ondřej Pejcha, who was also participating in one of our workshops in order to support his colleagues and maybe probably potential ERC grantees. And of course, I also give lectures at ad hoc events, other events on demand, and my daily Daily work consists of consulting by email, by telephone. I also offer individual consultations and propose a pre-screening. Of course, I'm not a scientist, so I cannot help you too much with your science, but I can check whether you fulfill all the requirements, whether any missing information should be added, etc. For financial aspects of your grant, you can also contact my colleagues, financial and legal and CPs. And I should stress that very similar support should be also offered to ERC applicants at other institutions or in other countries. So this is how we do it in the Czech Republic, but the similar networking opportunities for ERC applicants should be offered in other countries. Here you can see the list of the upcoming events planned for 2020. So you can see that we are now organizing the mock interview for ERC Consolidator grant applicants at the beginning of September. And I would like to invite all of you who are considering applying to an ERC call or would like to just to get more information about the ERC and would like to apply maybe in the future. There will be the National Information Day about the ERC on the 23rd of September, hopefully in a normal conference format. But of course, depending on the situation, the evaluation of COVID-19 pandemic, we will maybe forced to transfer our event into online session. And we are also planning to organize the workshop for the applicants, which should be held at the end of November, beginning of December. The first part, as I explained before. And then I would also like to say a few words about other opportunities which you can profit from if you are considering preparing your ERC project. So there is so-called Visiting Research Fellowship, which is offered at different countries. You can see the list of the countries and the agencies or organizations who are the providers of these fellowships. These fellowships are a great opportunity to visit a principal investigator of running ERC grant. So you can be granted, you will receive a fellowship who should cover your costs, and you will have a unique opportunity to work with the PI. You will be integrated for a certain period into his or her research team. You can consult your project and profit from this great opportunity. So this is in the format of fellowships or stays abroad. And the second opportunity I would like to mention is the program called ERC-CZ, which is the national funding scheme in the Czech Republic, with the allocation of approximately 40 million euros for this period 2012-2026. And this is the program which can fund high quality projects submitted to the ERC calls, starting, consolidator or advanced, which have been obtained A or B in the step 2 of the evaluation process. So I should stress that if you are interested in this program, there is an important rule that if you are granted, then there is one requirement that you have to reapply, you have to resubmit your ERC proposal within 2 years after starting your ERC-CZ project. So this shouldn't be, of course, considered negatively, but of course, on the other hand, it's a great incentive to those who want to resubmit their proposal and who were not discouraged. There is no limitation in terms of nationality. So if you choose the host institution in the Czech Republic, then you can also submit your application to this program after the evaluation received by the ERC. And if you want to get more information about this program, you can also visit the website. It is in Czech only, but hopefully in the future it will be also in English. In the last fifth call, if I'm not mistaken, 8 projects have been funded. So this gives you another opportunity, or this increases your chance to succeed and to get the financial support to carry out your research. And just a few words about the future. The new framework program, successor of Horizon 2020, Horizon Europe, which is supposed to be launched on the 1st of January 2021. You can see that the ERC stays under Pillar 1, Excellent Science, and we don't expect any revolutionary changes. So if you don't have time to prepare your proposal now this year, because now we have 2 calls open for ERC advanced grants with the deadline at the end of August, and also the 3rd call for proof of concept, which is specific. Then of course you can start preparing your project right now, because you know that there will be not many changes, let's say only small changes. And here is the calendar. It is of course preliminary, because it will depend on the adoption of the new work program, and before, of course, the approval of a multi-annual financial framework. But these are important dates for you, for those of you who are preparing your applications for the next call 2021. Of course, there can be some changes, but hopefully there will not, and the first calls will be launched according to this calendar. So this is in general for all participants, as we have here also those who are attending the conference and who are based in other countries outside the Czech Republic. But of course, if you need any help, those of you who would like to submit your proposal with the Czech host institution, don't hesitate to contact me. These are my contact details. And if anyone of you who is not based in the Czech Republic but will need any support, please don't hesitate to contact me too, and I can direct you towards my colleague, another NCP in another country, or help you to solve the issue. So that's it from my side. I hope I was not too long, and now I think I will check the questions, or I will give the floor to Christian. Yeah, so I think we can't see you, Christian.
Okay, sorry, I was muted. So first of all, thank you, Susanna, for your presentation. I think this gave a great overview on the offer of the national contact point in Czechia, but also of national contact points in general. And as suggested, I will now share the questions. And there's already a question directly to you. Okay.
We can see now your screen.
Yes, so there's a question from Yaro B. Are you also helping foreign applicants that intend to work at Czech host institutions?
Yes, of course. So I help those of you who want to apply with a Czech host institution, no matter of which nationality you are. So you can contact me and I will support you.
Good. And there's a request that you upload your slides to the agenda. I think we will all upload the slides to the conference
Yes,
website
yes.
and also share them to the registered participants via email.
Exactly. We will do it.
Okay, so maybe Susanne, you want to continue with reading the questions?
Yes, so maybe we can start with the first one, where we have 4 likes. Beyond the applicant CV, what are the different expectations for different ERC stages? For example, what is looked for in a consolidator that is not in a starting grant? So would you like to start?
Yes, maybe I can comment on this. So first of all, if you want to know the different criteria, the best place is to go to the ERC website and to download the ERC work program, which is the basis for all the evaluation work being done. So to your specific question, in the applicant CV, the questions are the same for starting and consolidator grant. There is no difference. And of course, you are expected, if you apply for a consolidator grant, that you have already more outputs and you already, you have probably already an own group and you want now to consolidate your group. Please keep in mind, if you're, for instance, just at the beginning of the eligibility window of the consolidator grant, this is of course not the same outputs and the same establishment are expected than if you're just at the end of the eligibility window. The evaluation panels take into your account your let's say your academic age in the eligibility window. Otherwise, in the other parts of the application, I would say there are no different expectations as well. So yeah.
Okay, so I think you answered perfectly, so no need to add anything else. And of course, if anyone, the person who was raising this question needs more clarification, he or she can contact me. I can see other questions. So we can take the second. Okay, so the first one, can you apply for an ERC for projects you are already funded to carry out, but don't have a team working on? Or should the ERC proposal be an orthogonal project?
Okay, maybe I can also reply to this one. First of all, this is a tricky question. Because let's start from like this. In your application, there's a section where you have to specify your existing funding. This is of course to avoid double funding. In general, you can also specify in your application that if you receive the ERC grant, you will turn down the other project. Now, concerning the specific question here, I understand it in the sense that you are already funded as an individual scientist, so you don't have a known group. So if you now want to do your research on a larger scale, and you want to build a team, so especially for starting grantees, a ERC project is the ideal opportunity. But of course, please keep in mind, you then have also to think large. If you want to build a team, it's quite natural that you need a larger idea and like more people contributing to the research. Of course, one expects also a larger output than on a project carried out by an individual. Of course, you can always apply for a orthogonal project. in this case, please keep in mind that there is a minimum requirement that you're expected to commit yourself to the ERC project. So for instance, for starting grantees, you're expected to work at least 50% of your working time on the ERC project. For consolidator, it's 40%, and for advanced grantees, 30%. Yes, I don't know if one of our grantees also wants to comment on the situation of working with different projects or on different projects in parallel. Do you have experience there?
So I guess I can answer because it's one of the problems I had. Well, it's a good problem to have that you already have funding. So, but I had a lot of help here as well from research services and from the Swedish national contact person because they actually told me also what to write. So the situation will vary country by country. But if your country is like Sweden, where most of your salary comes from external grants, it depends on the university as well. This is a good reason to say, I do have this present grant that is funding my salary and buys me out of teaching, for example, not completely, but to a large extent. And then the ERC allows me to build up a group on top of that. And they also suggested that I would have to go well beyond what I was doing in the original grant rather than just expand it. So if you see the 4 blocks that I had in my presentation, that's the way they suggested that I pose it. That one block was, in general, what I'm going to do in that grant that I'm already funded for, and then add 3 blocks, or at least that was and it worked out because there wasn't even a question of what is the overlap. The reviewers and the panelists accepted the fact that this was happening. So it's possible, I think.
Okay, thank you. So, Andre, you probably like to add anything?
Yeah, I guess for me the situation was that the ERC was on a bigger scale and somewhat different topic than my other grants. So I have a grant from national sources which actually complements the ERC. So the ERC is more theoretical and the national grant is more observational. So there is they complement each other, but they don't overlap. Yeah. So it's possible to do something like this, I guess.
Thank you. So now we can continue with other questions. One of the questions was what will be the application deadline for the ERC starting grants? So you saw the calendar and you will receive the presentations, or they will be also uploaded. But for starting grants, it will be in March. It will be the 9th of March. And we have here more questions. How does the timeline look? For example, how long did it take you to prepare the application, go through the process and start your project? Is the start date flexible? So the start date is flexible, I can answer, and so the rest should be answered by our 2 ERC grant holders.
Maybe I can just add something on the start date. There's some flexibility, but you are required to start your project not later than 6 months after the grant has been awarded. This is of course because otherwise at some point the novelty of your research would not be anymore the case, and maybe other researchers have already started on your project. So there's flexibility, but you're required to start not later than half a year after the award of the grant.
And for the rest, can we ask Katerina and Andre?
So I'll start with the time for preparation. And I think one important thing that I learned, maybe too late, I learned it when writing other grants, is that writing a grant is actual work and it takes a lot of time. And you enjoy it if you do it without the feeling like it's an extra thing, it's an extra chore. And I think one thing that writing grants, I kind of like doing that because it helps you plan and think about the long-term future for your research and your group. So take all your time, the time you need. And I don't know how much time people need. For me, it's, I guess, I need to do that for like a month without anything else. And I'm lucky enough that I have people and colleagues that let me disappear for a while, or only things that need to be done in emergencies that I need to deal with. So if you can carve yourself out time to think, then that's better. The courses that I've done suggest that at least 1 year before you start thinking about the idea, and then you build it up. But that, I guess, varies. So yeah, that's it really depends on the people, but I would suggest to enjoy the process as well, not just take it all on other ground. It's actually good if you can do that without too much stress.
Thank you. And Andrei, would you like to also share your experience?
I don't know. I guess my experience was peculiar. So the second successful grant I was writing or preparing while I was moving from US back to Czech Republic. So I only had about 2 or 3 weeks to actually write the proposal, even though I had just before we published a very important paper which was related. So I had a lot of material from that. And during the moving, I had few weeks to just think about the outline and organize everything in my head. And then it took 3 weeks to just write it down, what I had in my head.
Yeah, but you managed. You were successful, so it is also possible. But
yeah, I would not I would not want to do it again. I can tell you.
Okay, thank you. Thank you.
If I can add one thing is give people enough time to read it, because it also comes and yourself enough time to correct and iterate over it. That's one thing that I would do differently maybe in writing things.
Thank you. Yes, we have a very similar question related to the ERC advanced call, because now this is the last call in Horizon 2020, and one of our participants is asking whether it is advisable to still apply for the ERC advanced grant for this year, which has a deadline at the end of August, 26th of August, or is it better to apply for the next call 2021? So I would say it really depends at which stage you are. If you haven't started writing, it is feasible, but it will not be an easy time for you. Yeah, so what do you think, Christian, or would you like to comment?
Yes, so yeah, in the lines what you have just said, in the case you haven't already started your writing the grant, yeah, from what we have heard from the grantees, it's probably very unlikely that you can put something together that really makes it. So yes, from this also from the point of view of administrative stuff which needs to be done, it seems to be very challenging to me. I don't know, maybe Susanna, you can comment on the administrative part, also if this is feasible at all in this short time.
Yes, so for the administrative part, of course, you have to fill in some stuff, some information. It's true that quite a lot of details will be automatically pre-filled based on the PIC identification code of your institution, but of course, you have to fill in the budget, the information about your host, about you, and so on. And also for pre-screening, as it has been mentioned by Katerina, of course, if you want to send your proposal to other colleagues or to the ERC and CP, for example, it also takes some time for me to go through the proposal, and of course, you will probably not be the only person, the only applicant asking for support. So you should also plan it accordingly, and keep this in mind that not everybody will be as flexible as you would expect maybe, but it really depends on your decision, and if you are ready, or if you are really if you really want to apply this year, because otherwise your project would be obsolete, or for any reasons it is probably possible, but you will have really hard time. But if this person asking is from the Czech Republic, or want to apply with a Czech host institution and needs my help, so please contact me as soon as possible, and I will do my best. Okay, so we should finish, but still we have some questions. So what do you think, Christian? Do you think we will answer them, or we can also send the answers after the event?
Maybe we can quickly go through the questions,
So,
but limit ourselves to the 3 questions which are now here, and otherwise Slido will remain open, and we can then post maybe our answers in writing on the conference website.
okay. So we have here one question concerning resubmission. If you are unsuccessful, can you reapply with the same ideas but a rewritten application?
So first of all, yes, you can reapply with the same ideas. Of course, as you suggest, it makes sense to improve your application. In general, each submission is treated independently. So if you applied last year and you now applying this year, this will be seen as independent applications. However, please be careful. If your proposal is rejected at the first step of the evaluation, then you cannot reapply the next year. And if at the first step of the application, if your proposal was considered by the panel as non-competitive, then this period of blocking is even 2 years. So yeah. You need to pass to the second stage of the evaluation to be able to reapply the year after.
Yes, and we should also mention that all this information we'll find in the work program, and also with the guide for applicants for each of the specific ERC grants. So once it is published for the New Horizon Europe, we strongly recommend to visit the website of Funding and Tender Opportunities portal, or the website of the ERC, and read these documents, which are very useful. And then we have here a question: is it a requirement to have a previous grant to get an ERC? I'm not sure whether it is meant any grant, or how to understand this question.
So first of all, it's not required at all to have a previous grant, in particular for the starting grant. It also depends a bit on the field of research you're working in. In some fields, it's very easy to get grants. In other fields of research, it can be quite hard. Concerning ERC grant, we have a couple of double grantees, so grantees that received, for instance, a starting grant and then have been awarded a consolidator grant. But I can tell you, we have also seen examples where previous grantee applied for another ERC grant, and the new proposal was then not seen as competitive by the evaluation panel. So there's not a rule that you need a grant to get a ERC grant.
Does one have a chance of getting ERC consolidated grant without having own group yet? In the present academia, when jumping from postdoc to postdoc, it isn't always possible.
I would say this also depends a bit on your personal story, as Katharina also explained in her talk. And I would say in general it's possible, but it requires really to explain in the proposal your story and why you don't have a known group yet.
And the very last question, how long does the evaluation take place? When can one expect results for 2021 calls? So would you like to, actually, we can say that it takes approximately half a year, but of course, depending on each of, or depending on the type of the ERC, where there are more than one step. So of course, you will be informed about the results of each of these steps. And if you are then invited to the panel meeting, then of course you will know the results of the first, let's say, half of the evaluation process in between. But because of the delay, then we can expect the results at the end of 2021, if I'm not mistaken, if the deadline is in March.
Probably, let me think. Probably yes. For the starting grant, yes, but for the advanced grant, it will be in 2022.
Yeah, but you can also check this in the guide for applicants, or in the information for applicants, or in the work program once it will be published, where this calendar, including all these important dates, will be a part. And that's it. And there is the last question, which appeared. Is there a maximum number of times you can try to get the same type of grant? I don't think there is any limitation.
Well, there's a limitation of your academic age. For instance, for a starting grant, you can only apply until up to 7 years after your PhD. So this is the limiting factor there.
Okay, so that's it.
Yes, so
thank you.
Thank you everybody for participating to this ERC session. Thank you, Susanna, for your help with setting all this up, and special thanks to the grantees, Katharina and Andrzej, for their presentation, which gave really a lovely example of the ERC grants and the activities related to that. If you have any further question, we will keep the Slido open a bit after the end of the session, and we will try to get back to you to reply to the questions. And of course, you always can also contact us directly. Thank you.
Thank you. Thank you, Christian, also from my side. And I wish you all a very nice end of summer, and see you at another occasion.
Thank you.